Okay, we have the following task. We need to prove that sine half a pi plus 3 alpha over 1 minus sine 3 alpha minus pi is equal cotangent 5 over 4 pi plus 3 over 2 alpha. Okay, so first of all, let me start. Sine pi half a pi plus alpha. Let me write down this formula. Sine half a pi plus minus alpha is equal cosine alpha. So what do we have? Sine half a pi plus 3 alpha over 1 minus sine 3 alpha minus pi. So in numerator, sine half a pi plus 3 alpha, it's going to be equal cosine 3 alpha. Yes? Okay. Now in denominator, I need pi minus 3 alpha, right? Instead of at 3 alpha minus pi, because I'm going to use another formula where I will need pi minus alpha. So therefore, let me see. I'm going to do 1 plus sine pi minus 3 alpha. I change the sign, sign in front of sine pi minus 3 alpha and flip the pi minus 3 alpha. So, and sine, for this case, I'm going to apply formula. Sine pi plus minus alpha, it's going to be equal minus plus sine alpha. If you check it, you will see when we do pi plus alpha, we get negative sine alpha. When we have sine pi minus alpha, we get plus alpha. While in the case of half a pi, we get positive cosine one way or another, because cosine is going to be positive if you do the plus or minus sine half a pi. All right. Next, what we are getting here? We are getting cosine 3 alpha, and here I'm getting 1 plus positive cosine positive 3 alpha, because I have minus 3 alpha. Then I'm sorry, sine 3 alpha. Okay. Next. What can I do here? I have 1 plus sine 3 alpha, and I have cosine 3 alpha. With 3 alpha, I can't do much, but I can get for cosine of double angle, I can get formula, right? Let me write down. I'm trying to reduce this 3 alpha, sine 3 alpha, cosine 3 over 2 alpha, 3 alpha, and I'm going to use here formula, squeezing formula, cosine 2 alpha, which is equal cosine squared alpha minus sine squared alpha, and sine of 2 alpha is equal to sine alpha, cosine alpha. So, for this very reason, I'm going to write down cosine twice 3 over 2 alpha, right? Multiply and divide by 2, not to disbalance the argument. And one parameter plus sine twice 3 over 2 alpha. And this is going to be equal cosine squared 3 over 2 alpha minus sine squared 3 over 2 alpha. And here I am getting 1 plus 2 sine 3 over 2 alpha cosine 3 over 2 alpha. Okay, so what is gonna be next? I have cosine square minus sine square. So slowly I am simplifying to the level where I can get tangent or cotangent, because look here, I need to get cotangent, right? I need to prove that all this sine is going to be equal cotangent. So I'm simplifying up to level from parameter half a pi plus this alpha or 3 alpha minus pi. I splitted these parameters to get separate sine, cosine alpha or sine, cosine, half a pi or pi, whatever will come out. So to get it easier to get to tangent or cotangent, whichever will work, because from if we get tangent, from tangent to cotangent, it's only one step. Tangent is 1 over cotangent, right? So it doesn't matter which one I get close to. But I am splitting these parameters to separate so I can get closer to tangent or cotangent. I don't know yet which one I'll get close. Okay, so from here, look here, I have a squared minus b squared, right? Let me see if I can move this down even more. Okay. Okay, much better. Minus b squared. Yes? And this one here. So what am I going to get? Okay, let's work this out. I'm going to get cosine 3 over 2 alpha. Say I'm getting rid of square now. Minus sine 3 over 2 alpha. And then cosine 3 over 2 alpha plus sine 3 over 2 alpha. So first I separated parameters. Now since I have square, I'm getting rid of this square, right? So next I have here cosine alpha minus cosine beta, cosine alpha plus cosine beta. So actually, now what can I do here in denominator? I have 2 sine 3 over 2 alpha cosine 3 over alpha. Look what is interesting thing I can do here. Let me see if this will work. Yes, absolutely, it will work. So this one I'm going to represent as cosine squared 3 over 2 alpha and plus sine squared 3 over 2 alpha, right? Because why? We have cosine square alpha plus sine square alpha is equal 1. So 1 I opened up. Why? Because I saw here plus twice sine 3 over 2 alpha cosine 3 over 2 alpha. Look how beautiful thing we got here. This is a squared, b squared, and here I am getting 2ab. See that? Okay, so from here I'm getting cosine 3 over 2 alpha minus sine 3 over 2 alpha times cosine 3 over 2 alpha plus sine 3 over 2 alpha. And here I will have cosine 3 over 2 alpha plus sine 3 over 2 alpha squared, right? A plus b squared. Okay? Well, look what I am doing here. This I am canceling with this square. And I am getting cosine 3 over 2 alpha minus sine 3 over 2 alpha divided by cosine 3 over 2 alpha plus sine 3 over 2 alpha. So what did I achieve? I achieved the fact that I separated the parameter from the beginning that we had here, half a pi plus 3 alpha, right? Then brought it down to square and got rid of square, got to a simple angle here, okay? Now it's time to think how to move, do smooth transfer to tangent or cotangent. So, since I have, let me write down, cosine 3 over 2 alpha minus sine 3 over 2 alpha, and in denominator I have cosine 3 over 2 alpha plus sine 3 over 2 alpha. Now take a guess, what do we have to do to achieve tangent? What we have to do to achieve tangent? We have to divide by cosine, right? Cosine 3 over 2 alpha. Cosine 3 over 2 alpha. I'm dividing all across the fraction. Cosine 3 over 2 alpha. Cosine 3 over 2 alpha. This is gone. This is gone. And I'm getting 1 minus tangent 3 over 2 alpha divided by 1 plus tangent 3 over 2 alpha. So I would leave it like that, but we need to prove that it's equal, what was it? Cotangent 5 over 4 pi plus 3 over 2 alpha. Let me write down here. Cotangent 5 over 4 pi plus minus 3 over 2 alpha. This is what we need to prove. Okay, so once I got to the one step closer, I got tangent. Now I have to figure out how I'm doing transfer from tangent to cotangent. The way I have it here, I don't see how I can do it. I have here 3 over 2 and I have cotangent 5 over 4 pi. So in these cases, what do? I open the table of all formulas that are related to tangent. Tangent with cotangent or formulas of tangent, we can open it up. And this is what I found. So that's how you work, because you have to use this table. You can't memorize absolutely everything. Some formulas you can remember, but some of them that you don't use that often, you can't memorize. So it's a good idea to have printed your table, most of these formulas, and have it right next to you. And this is what formula I digged out. So I got the following formula: tangent alpha plus beta, tangent alpha minus beta. Because here I have, look, I get alpha minus beta, right? So from the 3 over 2 alpha, I have to move to 2 alpha and beta, right? And that's what I did. So tangent, I found it that tangent alpha plus beta is equal tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And when we have tangent alpha minus beta, it's different formula. We are getting tangent alpha minus tangent beta and divided by 1 plus tangent alpha tangent beta. Okay. All right. So how I can move from this format to this format? Okay, this is what I'm going to do. And what is interesting, I have here minus, right? Okay, this one I'm going to represent as a tangent pi over 4, because tangent pi over 4 is 1, right? Because sine pi over 4 square root 2 over 2, cosine pi over 4 square root 2 over 2, and when you divide, you get 1. So tangent pi over 4 minus tangent, let me see, tangent 3 over 2 alpha divided by, same way, tangent pi over 4 plus tangent 3 over 2 alpha. All right, so since I'm working with tangent, to get cotangent, I have to achieve numerator 1 and some tangent 5 over 4 pi plus minus 3 over 2 alpha, right? So it will get cotangent, yes? Since I'm working with tangent, to get cotangent, in numerator I need to achieve 1. I need to get 1. And in denominator, what tangent I have to bring to 5 over 4 pi minus 3 over 2 alpha, right? Okay, now I'm thinking how to get rid of this tangent quarter of pi minus tangent 3 over 2 alpha. Looking here, what I have in the denominators here, I have 1 minus, here is, this is plus, it's not gonna work for me. In denominator here I have plus, right? So if I divide numerator and denominator by this one, right? So in denominator I will get plus, hold on, was it 5 over 4 pi minus? No, it's plus, okay. I will get this plus, right? Will work for denominator here. But in the numerator, how to make in numerator? So if I divide, I need, okay, pi over 4, tangent pi over 4 is 1 by itself anyway, right? Now, and I need tangent alpha, tangent beta. So since here I have tangent pi over 4 plus tangent 3 over 2 alpha. So if pi over 4 is my alpha, and 3 over the pi over 4 alpha, and 3 over 2 alpha is my beta, so I need to divide by to get this tangent alpha plus beta, I need to divide by 1 minus tangent pi over 4 and tangent 3 over 2 alpha, right? And this, the whole thing, I will get this formula, correct? Okay, now I need this, divide the same thing in numerator and get 1. This is what I'm going to do, how I'm going to manipulate. So tangent pi over 4 is 1 anyway, so I can replace with 1, it's not a big deal. And next to tangent 3 over 2 alpha, I'm going to multiply by tangent pi over 4, because pi over 4 is 1 anyway, right? So I'm not disbalancing anything, writing 3 over 2 alpha. Can I do that? This is a nice manipulation. Let me see. And I will divide practically tangent. This is genius idea, no? Pi over 4 tangent. I bet you like this idea. This is beautiful. Let me bring this down. There we go. So, and what do we get? With big pleasure, I'm going to cancel this, and I'm getting 1. This is my long time waited 1 I was looking for. And here I'm getting a tangent alpha plus beta, which is going to be tangent pi over 4 plus 3 over 2 alpha. Yes? Okay. Now, how much is the period of tangent? Pi, right? So after every single period, pi, I'm going to get the same value for tangent, right? Like pi over 4. Yes? Which means I can do the following. Tangent pi plus pi over 4 and plus 3 over 2 alpha. Yes? Okay. And look what I'm getting here. 1 over tangent pi plus pi over 4. I'm getting tangent 5 over 4 pi and plus 3 over 2 alpha. And voila, we are getting cotangent 5 over 4 pi plus 3 over 2 alpha. And this is precisely what we needed to prove. Cotangent 5 over 4 pi plus 3 over 2 alpha. Okay, so I don't know about you, but I have enough of this one problem, so I'm not going to record next one. So digest this. And then I will record next.